Hey guys, I wanted to go over a few questions from the chapter 4 and 5 test that a lot of you guys missed. So I'm going to share the screen real quick with you guys. And let's pull up your test. All right. So most of you guys got number 1 and number 2 and number 3 correct. Number 4, some of you guys were off still in the standard deviation. Just remember, you can plug that into the calculator or plug it into Excel to get it. I think it was 2.41 or somewhere around there. I gave you credit if you were really close to that. Number 5 was one that a lot of you guys missed. If you had looked in your book, like I told you guys to do example 5 on page 308, it would have told you exactly what to do. The first thing you had to do was had to find the class midpoint, okay, which just means the average of the class. So you would add 41 plus 50 and divide it by 2, and you would get 45.5, and this would be 55.5, and 65.5, and 75.5, and 85.5, and 95.5. All right, the next step you would do is you would multiply the frequency times the midpoint. So 1 times 45.5 is 45.5. 2 times 55.5 is 111. 6 times 65.5 is 393. 8 times 75.5 is 604. 14 times 85.5 is 1,197. And 9 times 95.5 is 859.5. The next step was to find the sum of these. So add all these up in the calculator. You would get 3,210. And you also have to find the sum of the frequency. So add all these up and you would get 40. The last step is to take that number, the frequency times the midpoint, and the sum of those, which is 3,210, and divide it by 40. And what you would end up getting is 80.25, which is the mean. Okay. The next question is to how do you find the mean and standard deviation that will be affected if you added 5 to each piece of data. So let's say I just come up with a data value. I'm going to use 1, 2, 3, 4. The first thing you have to do is you need to find the mean and you need to find the standard deviation. I'm just going to use my graphing calculator, and we go to stat, edit, and we put in 1, 2, 1, 2, 3, 4. Okay, and then we go to stat, calc 1. And we get the mean is 2.5. And the standard deviation is 1.29. Now, part A says what happens when you add 5 to each data value. So instead of 1, 2, 3, 4, we're going to add 5 to this. So this will be 6, 7, 8, and 9. And now we want to see, okay, what happens to the mean and what happens to the standard deviation. So again, I'm going to go stat edit, and I'm going to put in 6, 7, 8, and 9. Go stat calc 1. And we get the mean becomes 7.5, and the standard deviation is still 1.29. So notice these are still the same, and this, what happens to it? It gets bigger by 5. So what would happen to the data? You would say the mean is increased by 5, standard deviation stays the same. All right, then the next time we're going to multiply these by 2. So this will become a 2, a 4, 6, and 8. And we want to say, okay, what happens to the mean? What happens to the standard deviation? So again, I find that 2, 4, 6, 8. So 1. The mean becomes 5. And the standard deviation becomes 2.58. And if you notice that, that's pretty much doubled. So 1.29 times 2 gives you 2.58. And 2.5 times 2 gives you 5. So what would you say happened? Well, you would say mean gets doubled and standard deviation is doubled. Okay. All right, so we're done with that one. The next question, number 7, is finding the z-scores. So this is where you had to use the z-score. I went over this video. I went over a lot of these questions on your video in the PowerPoint 5.2. And this is what the z-score chart looks like, okay? And so you had to use the z-score chart to find the z-score between two numbers. Now, the first one we want to find is from 0 to 2.3. Notice on your z-score, you're going from 0 to whatever z-score you're given, which is 2.3 on this one. So we go down to 2.3, and this would be the answer. So that means 0.4893 is what percent it would be. Move the decimal places 2 places to the right. So it'd be 48.93%. Okay. Let's see here. All right, just making sure we're recorded. The next question asked between 0.86 and 1.02. 0.86, 86, and 1.02. 0.86 and 1.02. All right, so what that means, if you draw it here, you're looking at 0.86 and then 1.02, and we want between this. But if you notice here, your z-score only goes from here to this number. It doesn't do between two numbers. So what you would have to do here is you would have to find it from here to the 0.86, and then you would have to find it from 0 to 1.2. And then to get this part, you would subtract these two numbers. And what I said on the PowerPoint is I said if they're going in the same direction, you subtract the two numbers. So I'm going to look up 0.8 and I go all the way down to 6. Okay, so that's 0.3051 and then 1.02. And that's 0.3461. And so what we do is we subtract these. 0.140, and we move our decimal 2 places to the right, and that would be 4.10%. Okay, so for the next one. The next one you want is between 0 and negative 1.8. Now, if you notice, we don't have a negative on our z-score, but the negative direction is going to be the same percentage. It's just going to the left, okay? So our number was negative 1.8. So we would just look up 1.8 here, and that would be our percentage. So it'd be 46.41%. The next one is between a negative number, okay, and they're both in the negative direction. So what you would do is you would look up 0.05 and 1.5, and you would subtract those two numbers, and you would end up with 41.3%. All right, and then the last one, I'll show you this one, is negative 1.2 and 0.8. Negative 1.2, negative 1.2, and 0.8. Now notice these are in two different directions. We have negative 1.2 and we have 0.8. And we want to find between these. So what you would have to do is you would have to find the percentage from here to here, and then the percentage from negative 1.2, which is the same thing as positive 1.2. And you would add these two percentages, okay, because we're going in different directions. So remember, I said same directions you subtract, different directions you would add the percentages. So we would look up 1.2, which is 0.3849, and you would look up 0.8, which is 0.2881, and you would add those together, and you would get 67.3%. Okay. All right, our next question is still dealing with z-scores, so let's take a look at that. It's actually using the empirical rule. There are drawings. All right, number 8. number 9, and then number 8, sorry. A certain type of cable has a mean breaking point of 150 pounds. So the mean here is 150 pounds. Our standard deviation is 8 pounds. What weight should we specify this so that 95% of the cables not to break supporting them? So if you remember, 95% means 2 standard deviations away from the mean. So if I draw this, our mean is in the middle. And if we go 1 standard deviation to the right, that means you would add 8. So this will be 158. And if you go 1 standard deviation to the left, would be 142, because we would subtract 8, right? And then we would add 8 again, and that would give us 166. And then we would subtract 8 again, and that would give us 134. Okay. And so this is 2 standard deviations away from the mean. So this is what they mean when you say, what weight should we specify so that we expect 95% of the cables not to break. So 95% of the cables would fall between 134 pounds and 166 pounds. This is the answer that I wanted. Now, some of you guys gave me a amount of weight between this, and I still gave it to you, but really I wanted the weight specification, which was 134 pounds to 166. Number 9, most of you guys got right. You used this formula. I'm not going to go over that one. And number 10, I did a problem like this, almost the exact problem before, but I'll go over it again with you. It's in the MBA. In the MBA, the distribution of heights has a mean of 6 feet, 8 inches, and it has a standard deviation of 3 inches. If there are 324 players, that's the amount of players we have, 324. How many players do you expect to be over 7 feet tall? So we want to know over 7 feet. So that will be your X, your data value. The problem here is they give you the standard deviation of 3 inches, and I have my mean in 6 feet and 8 inches. So what I would have to do is convert everything to inches. So I know there's 12 inches in 1 foot. So 6 times 12 would give you 72 inches. And then I add the 8 to it, and that would be 80 inches. And the same thing here, I would do 7 times 12 to go ahead and convert that to inches, and that's 84 inches. So if you notice here, we're given this value, and we need to find the z-score using our z-score formula. And so we would do 84 minus 80 all over 3, which is 4 over 3, which equals 1.33. Okay. So we want to find the percentage that are over that 1.33. We want this. Okay. And think about it, half of your percentage values is 50%. Okay, so that means that we want higher, okay, we want just this part. So what we would have to do is we would find the percentage from here to here, and we would subtract that percentage from the 50, and that would be what's left over. So let's go and look up 1.33. 1.33 is 0.4082. So this is 0.4082. So what we would do is do 0.50 minus 0.4082. And what we will be left with is our percentage that is over 7 feet tall, which is going to be about 0.092, which is 9.2%. Okay. But we want to know the amount of players that are over 7 feet tall. So what you would have to do is you would have to take your 324 and multiply it by our percent, which is that, and you would end up with 29.8 players. And we don't just have 29.8 players. This would be approximately about 30 players. Okay. All right, that's about it. If you guys have any questions about any of this, please feel free to email me, and I'll be happy to answer any other questions. Thank you.